Hey, good afternoon. My name is Tanaka, and I'll be giving a webinar today on using Terraform to create S3 bucket environments on AWS. Apologies if you came to this webinar expecting to see me using Terraform to to launch Kubernetes on AWS. If you remember from my webinar last week, I was actually experiencing some issues getting the Terraform provider from HashiCorp working on my environment. And just because with the short turnaround of 4 or 5 days, I still wasn't able to resolve those issues. But I'll have about 3 weeks before the next set of webinars. So hopefully by then I'll be able to, deliver the webinar that I initially promised. So just a quick introduction. Like I said, my name is Tanaka Mapnera. I'm a platform engineer here at Anant Corporation. I've been with the company for about 2.5 years now, and I currently live and work in DC. So just a quick overview of what this webinar is going to be. I am going to introduce you to Terraform. It is something I mentioned last weekend in my last webinar, but I didn't really get into it. So, just going to introduce what it is, what it's used for, what it can do, and provide a few use cases, and then show you a quick demo of me actually launching the S3 bucket environments on AWS. So what is Terraform? It is an open source infrastructure as a code tool that allows you to build, change, and manage infrastructure safely and efficiently. Terraform uses the HashiCorp configuration language, or ACL for short, to manage its environments. And it works across all major cloud providers. That includes AWS, GCP, and Azure. Infrastructure as code is the process of managing and provisioning the technology stack for an application through software. Resources can be defined as any environmental element, like a virtual machine or security group. With an infrastructure as code tool, you can control and edit your infrastructure as a code file, which allows you to easily change, copy, and distribute your infrastructure. Deploying an infrastructure as code tool eliminates the need to manually change configurations to manage your infrastructure. To run an application or to launch a data center, Terraform uses configuration files that describe the components needed to complete the task. Terraform creates an execution plan outlining how to reach the desired state, then builds the described infrastructure. When configurations change, Terraform identifies the change and creates incremental action plans to be applied to your state. Within these configuration files, Terraform uses providers to integrate with different services. Terraform is compatible with the vast majority of providers, mainly those with a focus on cloud applications. Terraform also uses some lesser known providers that allow other popular vendors such as Stripe and Auth0 to be managed in Terraform. So what are some advantages of Terraform? There are many advantages to using Terraform for the management of your environment. With Terraform, you don't need to have multiple clouds to support various applications. By creating a configuration file that fits the need of the organization or project, Terraform can manage multiple environments with the same workflow. Terraform also does a great job of managing state files. During the start of a project, Terraform creates a state file that is used to create plans and makes changes to the infrastructure. Before an operation begins, Terraform refreshes to update the state file with the infrastructure, and then the state file is used to measure configuration changes as they are made. Terraform compares changes with the state file to determine what changes should result in a new resource or resource modification. Other advantages include cost. Every business would like to find ways to cut their overall spending, and an infrastructure as code tool can help with that. With the use of an infrastructure as code tool, there's no need to hire a team of professionals to carry out necessary tasks during the process or build expensive data centers to house your files. Control. Terraform puts you in charge of your infrastructure. Because your resources are declared in code, you can track changes to that code over time, and with the help of version control system. Confidence is gained by those who use Terraform. The workflow allows for easily repeatable operations with a planning phase that confirms the requested action before Terraform completes the task. When initiating a command, the user will be prompted to review and confirm the changes before Terraform will apply the proposed plan. Collaboration. Terraform features a dynamic backend that doesn't restrict access, meaning multiple team members can safely work in the same configuration at the same time without the risk of losing work. And finally, consistency. Another big advantage of infrastructure as code tools is that they automate a lot of the processes an IT professional would have to handle, which cuts down on the change of human error. This means you'll get the same results from Terraform at any time it creates your declared resources. So Terraform is great for the deployment and management of cloud services with the ability to easily scale resources when needed. The software can then streamline those efforts of many companies in various industries. So these are a few use cases in which Terraform is used. So multi-tier applications. Terraform can be used to codify the setup required for Heroku application into ensuring that all required add-ons are available, but it can even go further. Configuring DNS simple to set a CNAME or setting up a Cloudflare as a CDN for the app. Best of all, Terraform can do it all in under 30 seconds without using a web interface. Self-service clusters. Terraform is an ideal tool for building and managing these infrastructures. Each tier can be described as a collection of resources, and the dependencies between each tier are handled automatically. Terraform will ensure the database tier is available before the web servers are started, and that the load balancers are aware of the web nodes. Each tier can then be scaled easily using Terraform by modifying a single count configuration value. Because the creation and provisioning of each resource is codified and automated, elastically scaling with load becomes true. Software demos. Software writers can provide a Terraform configuration to create, provision, and bootstrap a demo on cloud providers like AWS. This allows end users to easily demo the software on their own infrastructure and even enables tweaking parameters like cluster size to be more rigorously test tools at any scale. Disposable environments. Using Terraform, the production environment can be codified and then shared with staging, QA, or dev. These configurations can be used to rapidly spin up new environments to test in and then be easily disposed of. Terraform can help tame the difficulty of maintaining parallel environments and makes it practical to elastically create and destroy them. Software-defined networking. Terraform can be used to codify the configuration for software-defined networks. This configuration can then be used by Terraform to automatically set up and modify settings by interacting with the control layer. This allows configuration to be versioned and changes to be automated. Resource schedulers. Terraform is not limited to physical providers like AWS. Resource schedulers can be treated as a provider, enabling Terraform to request resources from them. This allows Terraform to be used in layers to set up the physical infrastructure, running the schedulers, as well as provisioning onto the scheduled grid. And finally, multi-cloud deployments. Terraform is cloud agnostic and allows a single configuration to be used to manage multiple providers and to even handle cross-cloud dependencies. This simplifies management and orchestration, helping operators build large-scale multi-cloud infrastructures. Now it is time for the demo. Okay, so we'll get up here. And in this demo, like I stated in the beginning, we'll just be deploying 2 environments to our AWS account. The prerequisites for this demo will just be the starter kit that I'll be using, which will be linked in our YouTube video. You also need to make sure that you have Terraform installed and you have updated your path on your machine to include Terraform's location. It can be installed using Chocolatey on Windows, Homebrew on Mac, and there are a bunch of curl commands for Linux. And the last dependency is that you have an active AWS account and that you have correctly installed AWS and configured your login credentials on your local machine. All right, so now we can get into the nitty-gritty of things. And we're going to open up Sublime Text to view our files. We'll put put that in full screen, and pretty much this is the repository we're going to be working in. So it's only a couple files. So we have the main.tf. This file configures the resources that make up our infrastructure. We have the outputs. This file specifies the two web endpoints for our dev and prod environments. So this is where we'll actually be, deploying the code that is being housed here in assets. We have variables.tf. This is where we declare the variables to mark the dev and prod environments, along with the region to deploy our infrastructure. And then lastly, we just have the Terraform.tf vars. This is where we'll define our region and environment prefixes. This is just showing us an example of how we would effectively create our own environment variables. So we can get started here by first of all renaming this to exclude.example. So we'll keep .vars, and we'll update this to US East 1 because that's where we are currently based. So then we are good there. And to just show you, and lastly, I just also wanted to go through the main files first. So obviously here we kind of have the provider declared. Again, this is just telling us which region. Over here, you'll notice we're specifying our first resource. This is basically a string value, and this will be the name of our environment in AWS. And then down here, we're also specifying the resource. So the first one is going to be the dev one, and this is just basically telling Terraform to create this said dev environment on AWS. If you scroll down here, it's basically telling the code to take this HTML file that's in our assets folder and deploy that to our AWS. Down here, it's doing the exact same thing, but instead for prod. Again, just to create the prod environment itself, and then here to deploy that file. So to start off with the demo, we're going to first enter in Terraform init. And basically, this is just going to initialize everything, just make sure our current version of AWS and Terraform matches with the starter kit that we're going to be using. Awesome. Seems that we were successful. And then next, we're going to put in the command Terraform apply. And basically, it's going to say, take the main file and then, push everything to AWS. The screen that you'll be seeing is that it kind of just goes through everything that has been declared, checks that everything makes sense, all the variables have been declared, and then it'll come back to us and ask us, enter a value, do you want to perform these actions? Just reply yes. So then it'll go through, and then at the end, it'll tell you, okay, this was complete, 5 of the resources were added, and then it'll tell you these are the 2 endpoints that we specified in the outputs, that TF file. So then that just tell us that, okay, our environments were created. To double check that, we can go back to our Amazon console over here. Okay, management console. S3. And voila, right there. So we have the dev and prod, and these were created just a minute ago. So now if we go to dev and prod, we should be able to navigate to the file that was deployed, and voila. So now we've officially created our environment. And for those of you wondering, yes, this is completely interactable, and you're able to play Tetris. And that's the kind of demo file that we have going on right now. So that's pretty cool. However, if you noticed, the way we deployed everything, we have both of our dev and prod environments being declared in the same file. So that's not exactly different. And the point of this webinar is to deploy it in different environments. So first, I'm going to go and say Terraform destroy. Spell something here. And basically, we're just telling Terraform to destroy our environments that we had set up. It'll come back asking us, do you really want to do this? We'll say yes. Boom. And then it'll tell us that Terraform is destroyed. So if you try to refresh this page, you'll get an error. So, To separate our configurations, we have to now we have to first organize the current configuration by splitting it into two different files. So first command is to copy over our main.file into dev.tf. And then we need to rename our old main.file to prod.tf. If you go back here, you'll see. So now main has been split up. We won't save that. So now we have a prod.tf and a dev.tf. Although our environments are in separate configurations, our variables.tf and our terraform.tf bar files contain all the variable declarations and definitions for both environments. So we now have resources split between environments in prod.tf and dev.tf, and our environments have unique identifiers to distinguish the region we are applying to. Terraform loads all the configuration files within the directory and appends them together, which means that any resources or providers with the same name in the same directory will cause a validation error. So for example, you'll see both in dev and prod, we have the same resource and provider. So obviously that if we were to run Terraform apply right now, as you'll see, we'll get an error saying, oh, we have all these duplicates, what's going on? Can't do that. So one thing that we gotta do, first of all, I need to change this. Sure, just use Java. Make it simple to comment out those codes. And then in both of our prod.tf and dev.tf files, we have to go through and make sure we remove any instances, any references of dev. So in prod, we're gonna remove the dev stuff. Oh, apologies, I think I removed the wrong thing. Yeah, because this is prod. So yeah, we're gonna remove all references of dev, which include this file right here. And then in dev, we're gonna come down and remove everything that references prod. All right, that should be good. And then just for the sake of you seeing how changes can be incrementally pushed, we're also just gonna update the length from 3 to 4 in dev, and then we should be good to go. So now if we go back here, let's say Terraform apply, should go through the file. Okay, no error warnings. Say, do you want to do this? Say yes. It's going through, it's saying everything was completed. And then again, it says we've got dev and prod up and running. So if we go back to console, we should refresh. Should see again 2. Okay, 623, which is just a couple seconds ago. And then if we navigate to the appropriate file, again, well, so now we've successfully, deployed our environment in separately. So we can close that out. Go back here, and let's go back to the code. Terraform destroy. Oh, however, if we want to truly separate our environments, we also need to separate the states as well. We can do this by using either directories or workspaces. For this webinar, we're going to be using directories just because they're more practical, and they represent environments that are truly different, whereas workspaces, the environments can be pretty much similar. It won't impact your work in that manner. Okay, awesome. So we've officially destroyed those environments. So next, let's go and first of all, we need to create a new directory for dev. Awesome. Next, we've got to move our dev.tf file to the dev directory, and we're also going to rename it to main just because it's going to be in its own space. Good to go. And then also we need to copy over all of our variable files. Output Terraform, TFRs, variables, TF. Should be good. Go here. Close these out. Say no to that. Go to the dev. Awesome. Seems that we have everything copied over. One thing you need to remember to do is down here when you're creating the resource, you need to update the path of content because your assets folder is now one level above. And the last thing that we need to do is go through all of these folders and remove any references of prod because this is strictly going to be for dev. I'm going to save that. Remove this prod. And we're going to move prod as well. Awesome. That should be it for the dev directory. So now we're going to go back for prod. Boom, boom, boom. So similar, we're going to move the prod.tf file to prod, and we're going to rename it to main.tf because it's going to be its own space. And instead of copying over the files, we're actually just going to move them because this is the last directory that we're making. Awesome. And then similarly, we just have to go back to our dev directory first. Got to uncomment these out because we're going to actually need those variable declarations. Sure, that's a Java. Bang. And then down here, we need to update this path. And then lastly, just go throughout these files and remove any references to dev. And wow, we should be good to go. So now all I need to do is just to go into each individual directory and see if our code deploys. So first of all, we need to run Terraform init because again, this is a new directory that we created. So it needs to just make sure all the versions are compatible with all of our declarations and definitions. Because that was good. And then we can run Terraform apply. It is also important to note that there is another step that you can run before Terraform apply, which is Terraform plan. Terraform plan does the exact same thing as apply, except for it doesn't give you the option to actually execute these plans. It's pretty much just like a debugger in a sense. Goes through your main file, make sure everything is correct, and then just tells you, all right, I've gone through the file, I've seen this is what you want to do, and if this file is executed, this is what's gonna happen. And then after that, you can run Terraform apply. So here it's asking us if we want to apply our changes. You say yes. Bam. All right, it says it was successful, and it says the output was to the dev site. So that means if we go back here and refresh, we should only have dev up. Sweet. Seems like dev is good. So if we go back, cd to prod, Again, gotta run Terraform init to initialize everything. Now successful. Terraform. I'll just show you exactly what Terraform plan looks like. See, so it's pretty similar, just like apply, but it just won't give you the option to execute. And yeah, it'll just kind of tell you, you know, all these are the changes that are going to be made. And then after, we can run Terraform apply. Say yes, please push these changes. Bam, that was complete. It says the output prod endpoint was deployed. So again, we can go back to our console, refresh, and we should see prod there as well. And voila, it is there. And then obviously last is just to check to make sure that everything did go smoothly. Check prod as well. All right, seems like dev is working. You're able to play some Tetris. And if we go to prod, that was working as well. Awesome. And that's about it for this demo. As you can see, we've now successfully deployed both a dev and prod environment to AWS using Terraform. And while I wrap up this webinar, I may as well just post this in the chat if anyone would like to play around. Oh, no, that's the wrong place. There's a Terraform plugin for VS Code. It's Sublime. There may be, yeah. I forgot to check for Sublime. So let's go back here. So to just wrap up this webinar, these are the key points to take away. Infrastructure is described as using a high-level configuration syntax. This allows the blueprint of your data center or project to be versioned and treated as you would like any other code. Additionally, infrastructure can be shared and reused. Terraform has a planning step where it generates an execution plan. The execution plan shows what Terraform will do and when you can call apply. This lets you avoid any surprises when Terraform manipulates infrastructure. Terraform builds a graph of all your resources and organizes your resources in parallel. Because of this, Terraform builds infrastructure as efficiently as possible, and operators get insight into dependencies in their infrastructure. And lastly, complex change sets can be applied to your infrastructure with minimal human interaction. With the previously mentioned execution plan and resource graph, you know exactly what Terraform will change and in what order, avoiding many possible human errors. And that will do it for my webinar. As always, if you liked what was presented today, or would like to chat with us to just see on what other projects we could collaborate on, please don't hesitate to reach out. We're always looking to meet and work with new people. And before we close out this webinar, are there any questions? Okay, well, if nobody has any other questions, I'd say thank you very much for coming to this webinar. Again, by the time we have our next round of webinars, hope to get everything resolved so that I'll be able to deliver on the, getting Kubernetes up and running with Terraform. But thank you very much for being here, and I'll see you guys next time.